In this video, we're going to be looking at some of the unique properties of water, and so we're going to start off by looking at water as a liquid. So here I've just got an image, a beaker, it's full of water, and if we zoom in super close at a molecular level, these represent all of the molecules of water, and water is H2O. It is two hydrogen atoms, those two smaller spheres, and one oxygen atom that have been bonded together. One of the unique properties of water is this idea of what's called hydrogen bonding, and as we look at all of these molecules, when it is in its liquid state, water will have an attraction where these hydrogens have a partial positive charge and they're attracted to the partial negative charge of the oxygen. Now, this isn't like an ionic bond like when you had salt where you had a positive sodium and a negative chloride, all right? It's similar in that attraction, but it's not as strong of an attraction as an ionic bond. And that particular property is what gives water, for example, its surface tension or its ability or its properties of cohesion and adhesion. Now, when we look at any substance, it's made of molecules. All of those molecules are always moving, and when they're in the liquid state, they're going to be vibrating, and so they're vibrating back and forth. And as we increase the temperature of a liquid, specifically as we increase the temperature of water, those molecules will vibrate more and more as their energy is increasing. And because those molecules are vibrating, they're bouncing into each other and they're colliding. And the more energy that they have, the more we said they're vibrating, the stronger those collisions, which is going to be pushing them further and further apart. So to recap, as we increase the temperature of water, we're increasing its kinetic energy, we're increasing the velocity with which those molecules are vibrating, and as that velocity increases, it results in greater collisions, which are spreading the molecules out. So high temperature water has molecules that are spread further apart than low temperature water. Now, as we decrease the temperature, the reverse happens until we start getting real close to the freezing point, and something very unique happens. 4 degrees Celsius is going to be the point at which water is most dense. When water is colder than 4 degrees, the molecules no longer get closer and closer together. They start to do something really unique. And if we look at water as a solid here, it has formed what we call a crystal structure. Now, most substances do not do this when they go from a liquid to a solid, but water, because of those unique hydrogens, having that partial charge and that oxygen with that negative charge, it forms this regular repeating network or pattern that we call a crystal type structure. If you've ever left a bottle of water in the freezer for too long, you know that water expands or gets bigger when it's frozen as ice or when it's a solid, and that's exactly true. Because of this crystal structure, you'll notice there's more space in between the atoms than there was when it was water. This is also why, or when it was a liquid, excuse me. This is also why ice floats on top of water, because ice as a solid, we said, is more spread out, making it less dense than the liquid water. Keep in mind that although this is a solid and these molecules are locked in place, they are still vibrating. They're just vibrating with less velocity than they were when they were in a liquid state. Lastly, if we go the opposite direction and we look at steam, here we have a tea kettle that was on the boil. It's creating steam. Steam, also called water vapor, is just water molecules that have enough velocity that they're no longer trapped in a liquid state and they're free to move around and about. And you'll notice in this picture here, this is kind of just trying to depict that the molecules are speeding about as they move. You'll note steam, right? If you've ever been burned by steam, it can hurt very, very badly, even though it's really just a small amount of water compared to what was in the pot. And that's because it has a tremendous amount of kinetic energy as compared to the water when it was in its liquid state.